So there are three different examples here that are pretty similar but have very different results. This is a little different because it's got a radical in it, but still we're looking for the very biggest power in the numerator, but that 3 has a consideration. So now we're really looking at negative 64 x to the 7th to the 1/3. And in the denominator, the second power is the largest. So as I look at one over the other, we have x squared, well 7 and 1/3, we multiply our exponents. So this is really negative 64x all to the 7 over 3. Well, what is that as an actual number? 7 divided by 3 is 2 1/3. And so now we can see 2 1/3 is bigger than 2. So this is really simplified, a negative number because of that negative, x to the 2 1/3 minus 2, or negative x to the 1/3. Now as I put a big number in, like maybe negative 1,000. Oops, sorry, but that's a positive 1,000 because we're going to infinity. We would have negative 1,000 to the 1/3 power. And so that answer we get negative 10. But if I were to try a positive 1,000,000, let's just see what happens to this result as I plug in a bigger number here. When I have negative 1,000,000 to the 1/3 power, this is now negative 100. Well, if I added more zeros, this would be negative 1,000. It keeps getting smaller and smaller and smaller. So this answer is negative infinity. What did we do? Again, we just did what we've been doing all along. We're simplifying, but now we have a radical, so it's just a little bit more challenging. Now we're going to move on to this next example. Again, we're looking for the largest power in the numerator, but remember that radical matters. And in the denominator, this is supposed to be a 3. Looks like this is the largest. So we have 27 x to the 9th all to the 1/3, or the cube root, over negative 2x cubed. Well, as we distribute this power in here, we have 27 to the 1/3, that's like the cube root of 27, times x to the 9 times 1/3. Well, that becomes 3. And in the denominator, we have negative 2x cubed. So simplifying a little bit more, cube root of 27 is 3. So I'm going to have 3x cubed over negative 2x cubed. Well, this time, my x cubes cancel out, and I have a horizontal asymptote at y equals negative 3 over 2. So that's my limit as x approaches infinity, negative 3/2. Keep in mind, if you had wanted, you could have just plugged a big number in for every one of these x's. But that would have been kind of cumbersome. It's easier just to simplify, but you do have to take the cube root of 27, and you could do that on a calculator if you wanted. Now let's look at the last example. Again, the biggest power in the numerator is a 5, but also a divide by 3. And in the denominator, we have x to the 4th. So we're going to have 5x to the 5th, all to the 1/3. And that's like saying 5 to the 1/3 times x to the 5/3. And in the denominator we have x to the 4th. Well, hopefully you can see that the denominator is bigger than the numerator. And whenever we see that, we know our limit is 0. If you don't remember, just on a calculator, plug in 5 to the 1/3 times a big number to the 5/3 over that same big number to the 4th power. Let's see what we get. We know we're searching for 0. That's going to be our answer because x to the 4th is bigger than 5/3. But let's just see what the number gives us, the calculator. Our calculator gave us that negative exponent, which means we really have 0.0001235368. That's really what that is. Well, that's basically 0. So that limit would be 0. Now, try the section in your assignment that says limits to infinity, type 2. This video will get you ready for those kind of problems.